Okay. Good morning. Again, this is our second video going over 6B. Um, and so I'm going to go over these two proofs on the back and sort of how they're supposed to look and how we're supposed to sort of fill these out. Pre-AP classes, you're probably going to have to do one of these blank. Regular classes, you're going to sort of have some of these partially filled in or whatever when we do our quiz, whenever that may be. But for now, it's still good for us to sort of understand the structure of these things and try to fill these things in. Okay. And so I'm going to sort of jump, you know, back and forth here and talk about how to do these sort of in simple layman terms, like how we do on the back of the 6A notes, and then how we sort of put it in an organized fashion here, like we do on this proof. Okay. First things, we always want to do a few things. So we always want to start, okay? So at the top of the proofs, we always want to start with the givens, okay? So a couple of rules of thumb here that I'm going to put just to make sure we're cool here. We want to start with our givens, okay? We're going to start with our givens, okay? So we're going to put all those on the top, okay? And we're going to end with what we're trying to prove. We're going to end with what we want to prove. Okay. And the justification for what we want to prove, again, if we're proving triangles to be congruent, which is what we're doing here, our justification for that is either going to be, side, 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 or side, or angle, side, angle, or one of those that we did on the 6A notes. Okay. So, starting with our givens, our last statement is going to be what we're trying to prove. So in this one, the last statement will be triangle RST is congruent to triangle UST. And justification is either going to be, side, 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 or side, angle, side, angle, or one of those bad boys. Okay. So that's that. And so here we're going to have all of our information that we have organized here. And in this column on the right, we're going to have our justifications for it. Okay. And so our justifications may be given and maybe some information that we got that we talked about from the first page on the definitions and stuff like that. So let's sort of do this one together, and we'll do this next one together as well. And I'll sort of talk you through how to do these bad boys. Okay. I'm going to erase all this stuff up here. So if you need to pause the video, pause the video. If not, we're going to move forward. Okay. So first thing, we want to start with our givens. Okay. So we're given two things here. So we're given an angle R is congruent to angle U, which they're marked there. And we also see that ST bisects angle RSU. Okay. So we have two givens here. All right. So our first given is angle R is congruent to angle U. All right. And our second given is acting all crazy here. ST bisects angle U. Okay. Those are our first two statements, okay? And the justification for both of those is going to be given because they give us that information right there. Okay? So the reason we can say that angle R is congruent to angle U and that ST bisects angle RSU, okay, those are given and given. Okay. Now next, based on the information that we're given, we can come up with some more information. Okay. So angle R being congruent to angle U, again, that's another more that we can do with that. Although we know that angle R being congruent to angle U, that gives us one pair of angles. Okay. So we have one pair of angles set to go. All right. We should have another pair of angles set to go since we know that ST, which is this line segment right here, bisects angle RSU. Okay. So now by the definition of bisect, if we go back up, Okay, by definition of bisect, if we have an angle that gets bisected, it gets cut into two equal pieces. Okay, so the equal pieces right there would be those two things right there, RST and then UST. All right, and so that's what we can say next, and we can only do that because we are already given the information that ST bisects angle RSU. Okay, so we can type in angle RST congruent to angle UST. How do we know that angle RST is congruent to angle UST? Well, because of this. Okay, they gave us that ST bisects RSU. Okay, so by the definition of bisect, we could say this little angle is congruent to that little angle. Now, what that also gives us is that gives us another pair of angles. Okay, so now we have two triangles where we have two pairs of congruent angles. Okay, and so we're probably going to be either looking at angle side angle or angle angle side. Okay, because those are the two triangle proofs that we have that that have two A's, that have two pairs of A's congruent. Okay. Now, next thing we're looking at this triangle here. We don't have any other given information that we really use. Okay. But we should be able to see that these two triangles share a side. Okay. And going from what we did on the definitions, that's something that we have to sort of be aware of when we're doing these things. And sometimes they may not give us stuff outright in terms of telling us here, but we should be able to see it to say, okay, well, they share a side, or they have this, or they have that, so we can use one of our definitions above. Okay, so if we run out of given information, we could always look at our definitions above on these 6B notes and see, is there anything else that we can maybe use? Okay, in this one, they share a side. Okay, they share a side. All right, it's ST, they share that side. So we could say, okay, that ST is congruent to ST. Okay, they share the sides. And again, that's the rule for that is the reflexive property. Okay, when something is congruent to itself. So if they share a side, in proof language, it would mean that ST is congruent to ST. Okay, so those two pairs of sides are congruent to each other. Okay, so that gives us a side. Okay, now it could be angle side angle or angle angle side. However, for angle side angle, the side needs to be in between the two pairs of congruent angles. So if it was angle side angle, we would need RS to be congruent to SU because that's the side in between the two angles, and that's the side in between the two angles. Okay, that's not the case. So the triangles are going to be congruent, which is what we want our last statement to be. Okay, triangle RST is congruent to triangle UST. And the reason for that is going to be angle, angle, side. Okay? Angle, angle, side. So everything that we did, the first couple steps of this thing, are either going to get us our A's or our S's or something like that. Okay? And once we have enough of that information, we have, three things, so whether it be SSS or SAS or ASA or AAS or whatever. Once we have our three things, that should be enough to prove the triangle is congruent. Okay, so triangle RST is congruent to triangle UST by angle, angle, side. Okay. Again, if we were to look at it just plainly, okay, without all this other stuff, and without organizing this as a proof. Now, again, it's very important that we know how to organize and document all this information. But if you want to sort of sketch it out first up here on the picture and then sort of fill the table in as you go, that's another option. As long as you know that the givens go up front and then, the statement goes on the bottom here, and then you can kind of fill in the middle as you go. So they gave us R and U being congruent. ST bisects RSU, so that makes this congruent to that. All right. And they share the side. Bang. So we have angle, angle, side, making them congruent. There you go. So, you know, a lot of this stuff we can figure out without having to do this whole proof thing. But proofs are important, and you're going to need to know how to do them for, you know, some higher level math. So it's good to be able to take your information, organize it as such. It's almost kind of like the scientific method, if you want to think of it that way, where you take your given stuff, and from the given you get some more information, and so you get enough information to draw the conclusion that you're looking for. Trying to conclude and prove that this little triangle on the left is congruent to that little triangle on the right. Okay, so the whole method of doing this is to organize all the information until we get enough to prove what we want to prove. Okay, so if we go on to this next one. All right, so here we have two givens. All right, and so our two givens is that QT bisects SP and SP bisects QT. All right, so I'm going to try to write that in here. So if we have QT bisects SP and SP bisects QT, all right, and so those both things are both given. Okay, both of those things are given right there. Now, we talked about the definition of bisect on the definitions on the top of the 6B notes on the first 2 pages. And so we're looking at this thing here, and we have bisect. Okay, so bisect means cut in half. So SP is getting bisected by QP, so that'll tell us that SR is congruent to RP. Okay, and that's by the definition of bisect. Okay, bisect means cut in half, cut into 2 equal pieces. So SR has got to be equal to RP, congruent to RP. Likewise, QR has got to be congruent to RT because SP is bisecting QT. Okay, so QR is equal to RT for the same reason, by the definition of bisect. Okay, we have 2 bisect things here. SP is getting bisected by QP, and SP is being bisected by QT, and QT is also being bisected by SP, so they bisect each other. Okay, so what we have is now we have S. Okay, so this side is congruent to that side, and we have this side congruent to that side. Okay, so we have S and S, so it's either going to be SAS or SSS, say side angle side or side side side. Okay, so we have to think about, okay, do we have the information to prove this side QP is congruent to side ST, or do we have the information to prove that these 2 angles in here are congruent? Okay, we're smart. We should see that we have the information to prove that angle QRP is congruent to angle TRS. Okay, so angle QRP is congruent to angle TRS. Okay, why? Because again, we have, let's think about this here. We have line, 2 lines intersecting with each other. These 2 angles are not adjacent to each other. They're across from each other at the X. So those are vertical angles. Okay, and vertical angles are congruent. Okay, so that's why we can say QRP is congruent to angle TRS, is because we have the 2 angles that are vertical to each other. So now that gives us our A. Okay, so we have 2 sides and an angle. As long as a pair of angles is in between the 2 pairs of congruent sides, then we're good, which is what we have here. Okay, so the angles in between the 2 pair of sides there, and the angles in between the 2 pair of sides there on both sides. So now we could say that triangle QRP is congruent to triangle TRS. And the reason is side angle side. Okay. So again, a proof is just sort of a scientific method type thing in geometry where we organize all of our information in order to solve for that. Okay. So that'll get you all the stuff you need for the 6B notes, and then you'll use this information to do 6C. And you can sort of do 6C on your own. And again, some stuff will be totally filled in, some stuff will be totally blank. So you're just going to have to fill in what you can, and hopefully, you know, again, if we know enough of the structure that the givens go in front and that, you know, our congruent statement goes in last, we may be able to fill some of the stuff in. And also, just FYI, you know, these areas here are kind of interchangeable. Okay. So, you know, if you wanted to put the vertical angles before all that bisect, that's fine. You know what I mean? That's really not a big deal. Same thing over here. If we wanted to put, you know, the reflexive property before the definition of bisect, that's fine too. As long as the givens are always first and then the congruent statement is always last. As long as that's the case, you know, we're good to go. So that's that. Any questions, please let me know. And thank you and have a good day.